Greetings, class. I hope this video finds you well and rested and having had a wonderful break from school. And hope you had a good Thanksgiving break, possibly with family. But now it's time to enter the home stretch into the last portion of our class. This week, the only thing you need to do for this week is a handful of F tests, specifically one-way analysis of variance. The only thing you'll need to complete this week will be a problem set where you will be asked to conduct one-way analysis of variance and also take a quiz as well on the subject matter. I have placed just a couple of items, course material items, for hopefully your benefit on the Blackboard site, and I wanted to take this opportunity to go over those specifically two pieces of information in particular. For some of you, depending on how far you got into the previous week's material regarding one-way ANOVA, this might be review. I hope all of you use this material, this video, and the handouts that I prepared for this week in order to help you understand and interpret and execute analysis of variance. So the material, the handout I'm going to refer to, which is on Blackboard, is called Setting Up a Proper F-Test with Drawings and Explanation. I know that's a long name, but it's also on the sheet itself. Setting Up a Proper F-Test with Drawings and Explanation. So if you don't have that handout, you might want to pause this video and go get it off of Blackboard. It is a 6-page document, and that is what I will be referring to in this YouTube segment. As the name of the handout suggests, this is all about making sure that you understand how to set up an F-test using the appropriate information. So take, for example, sample problem number one, starting with the first page of the document. I give you a null hypothesis. It's a little bit of a truncated hypothesis, but I hope it's relatively easy to understand. The null hypothesis, also known as the hypothesis of equality, is this: 6 cities are all equal or the same regarding their average snowfall. So we're comparing 6 cities regarding their measure of snowfall. The 6 cities, just for the sake of storytelling, are Chicago, Detroit, Minneapolis, Bismarck, Buffalo, and Cleveland. And I made a point of noting the unit of analysis. The unit of analysis for this problem that I'm asking you to assume is the total winter snowfall for 8 randomly selected winters for each city. So in other words, we've got 6 cities: Chicago, Detroit, Minneapolis, Bismarck, Buffalo, and Cleveland. 6 cities. We've selected 8 winters from each of those cities' history. So 6 cities times 8 winters would be 48 pieces of data total. So N sub tot is 48. Now, if you haven't seen the last YouTube postings, you might, and also if you haven't read the related chapter, you might wonder what N sub tot is. So please review that before you go any further if you haven't viewed that material yet, or if you need a refresher. N sub tot, incidentally, is simply the total number of cases involved in the analysis. So basically, I've set up this problem. I've asked you to test the null hypothesis at the 0.05 level. I've asked you to assume six groups of data, right? The data came from 6 cities. A total number of cases of 48 cases involved in the analysis. And I also ask you to assume, we're not doing any math on this handout, I'm asking you to assume a data-generated F value of 2.90, data-generated. So that means I'm asking you to assume the total number or the total amount of between-group variance if you had been asked to do the math. So if you had been given the raw data itself and gone through all the motions, this is the number that you would have come up with, 2.90. And that number represents the true amount or total amount of between-group between group variance. Now, go ahead and go to the second page of that handout. It looks like this, and it's called sample problem number 1, drawing key, right? So here's essentially where I solved that problem. I started off by drawing the F probability distribution right there. We already knew we were asked to test the null hypothesis at the 0.05 level, so that's noted right here. I made a tail and wrote 0.05. That means that this part has to be 0.95. I then calculated or found the degrees of freedom, df, between the groups, degrees of freedom for between the groups, and that value is 5. The formula for df between, as you may recall, is k minus 1. K is the number of groups involved in the analysis. We're asked to compare 6 cities, so that means k equals 6. 6 minus 1 is 5. So degrees of freedom for between is 5. Degrees of freedom within, that, if you recall, is n subtote, which we know is 48, minus k, which we know is 6 cities. So n subtote is, df within is n subtote minus k, or 48 minus 6, which is 42. And then our alpha level is 0.05, which we already know here as well. So this is the legend. df between is 5, df within is 42, alpha level of 0.05. I then consulted the F table. Right? Degrees of freedom for the numerator is 5. Degrees of freedom for the denominator is 42. Again, all that was contained in the last series of videos about one-way ANOVA. And when I consult the table, and you can review how to do that if you need to, when I consult the table, I find that the tabled F value is 2.44. That is the amount of between group variance that we could expect to occur by chance alone, or up to the amount that we could expect to occur by chance alone, given certain conditions. And what are those conditions? Well, 6 groups, or DF5, a total of 48 cases, or DF between of 42, and an alpha level of 0.05. Using that information, that is exactly, those are the 3 pieces of information that we used to find this tabled t-value of 2.44. Now, you may recall from the first sheet, I'm asking you to assume a data-generated F value of 2.90. Well, where would a data-generated value of 2.90 fall? If I know that 2.44 is here, that's the tabled F value. That means my data-generated value fell beyond that. It fell in the tail, right? Therefore, we reject the null hypothesis. Reject the null hypothesis of equality. We observed more between group variance than could reasonably expected to occur by chance alone. The 6 cities are different significantly regarding the actual amount of snowfall. And then you can see all of that explained. Now I'm back on the first page of the handout. You can see all of that explained right here in what is probably a lot of hopefully beneficial detail. So I ask you to go ahead and view the drawing that I just showed you. View the drawing and consider all of the following. And then I explain degrees of freedom between and how we arrived at that. Degrees of freedom within, how we arrived at that. A reminder that we are testing the null hypothesis at the 0.05 level. I explain where the tabled F value came from. And then the fact that we observed more between group variance than we could expect to occur by chance alone. That's why we rejected the null hypothesis. I am going to go ahead and go through the other 2 examples that are contained in that handout, but as I've mentioned before, I like to keep these segments to less than 10 minutes. So I'm going to go ahead and shut this off and then create another one I'll hopefully be able to cover the other two examples in one segment.